This is Mr. Anderson for Kellogg Community College. Today we are going to be looking at Chapter 3, Section 2, looking at more properties of inverses, and we'll get into some, on the second of these two videos here, we're going to get into some inverse cosecant, inverse secant, and inverse cotangent. But to remind you, we had three inverse formulas that we used in Section 3.1. So we had the main inverse, whoops, get my pen started here. We have these three main inverses. We have the inverse sine of x, and then we have the inverse cosine of x, and then we have the inverse tangent of x. They also mean, if you want to actually, if your x was a theta, which is how we're mostly going to be using our inverses, where the x will be the angle, whether we measure it in radians or degrees, we can flip-flop the x and y around and solve for our theta in this case, but this will mean that we can actually use the sine properties to find our x. We can use our cosine properties to find our x, and we can also use our tangent properties to find our x. This is also important when we talk about boundaries too, because this is where x is between -1 and 1. Our unit circle obviously has between -1 and 1 on its width and its height. If you look at the graph, you will see this a little bit more in particular, but I think a lot of students just kind of gel with this idea. Whereas if you should really look at the graph of tangent, because tangent goes infinitely. When you look at the inverse, it goes infinitely from left to right, and it's good to actually graph these to see these kind of how they change, how they oscillate, and how they move. It's quite fascinating. Now, there's also boundaries for y, and these boundaries are very important because I set up my quadrant perspectives here. And these quadrant perspectives are very important because we will be looking at inverse sine and inverse tangent in the first and fourth quadrant. We will also look, oops, sorry, that's a negative, and that's the positive here. Sorry about that. We will be looking at cosine between the first and the second quadrant. So first and fourth for inverse sine, first and second for inverse cosine, and first and fourth for the inverse of tangent. You'll notice too that the bounds here, the inverse tangent cannot actually be at -90 and 90 degrees because you would be dividing by 0, which would give you a division of 0 error. So what we're going to do is take a look at our unit circle. Since we're dealing with cosine, we're going to look at our unit circle for 1/2, where cosine is 1/2. So because we're solving for the x right now in our head. So where is cosine equal to 1/2 on the first or second quadrant? And that's going to be at pi/3. So now that we figured that out, since the inverse sine of 1/2 is equal to pi/3. Again, you probably won't write out all these steps, but this is where we're getting it from, because the cosine of pi/3 is equal to 1/2. See, all of this, again, we're probably not writing this down. You're probably just looking at the unit circle saying, okay, I want to find theta, I want to find that angle measurement in radians or degrees, where we have 1/2 for cosine, and then that would be at pi/3. Then the problem tells us, well, now take the sine of that, and the sine at pi/3 is square root of 3/2. So we've now found our exact value. Here we have the sine of -1/2. So where in the first or fourth quadrant is that? And it's at -pi/6. Now I know you probably want to give me the positive rotation value, which is 11pi/6, but really we're going to have to go with -pi/6 because that's in our boundaries there. And again, if you don't show your work here, this little thinking of it as 11pi/6 is irrelevant, but it really, to make the math stick, this is how it is. And this will be the the tangent at that 11pi/6 or -pi/6 is going to be -square root of 3/3. If you've memorized the unit circle or you have it in front of you, you can see how quickly these problems can go, and that's actually to your benefit. 1/2, again, from above, this is negative pi over 6. So the cotangent, I put cost, yay. The cotangent at negative pi over 6 is this flipped on its head, which is the square root of 3 with a negative in front, since we're in the fourth quadrant. All right, we're going to finish up this first side, and you're going to see that this is pretty straightforward here. I'm going to do problems 4, 5, 6, and 7 and on the front side, and then we're going to go to the second side, and things aren't going to get really bad until we're trying to find inverses of things that are not on the unit circle, and then we're going to have to do a little Pythagorean theorem to get that. So what I have here is the square root of 3 on the first and fourth quadrant. The tangent is at the tangent of square at pi over 3, the tangent is square root of 3. So let's take the secant at pi over 3, which is going to be 2. Okay, so on the first and fourth quadrant, where is negative square root of 3 over 2? For sine, well, that's at negative pi over 3. This is the idea of using that negative angle rotation. We can't, we should not go outside of our boundaries, even though there is a positive angle rotation, but it's, bigger than what we need to be between, it's not negative, between negative pi over 2 and pi over 2. So this is going to be, okay, so what is the cosine of negative pi over 3? It's going to be 1/2. All right, so the next piece over here, this is going to be in the second quadrant because that negative square root of 3 over 2 for cosine is going to be at 5 pi over 6, almost at 90 degrees there. So what is the cosecant at 5 pi over 6? That will be 2. And then here we have the cotangent of 2 pi over 3. This is going to be at negative. Okay, now this case of this problem, this is a little different because now I know the theta. I know that this is my angle here. This is the angle's 2 pi over 3. So what's the cotangent at this spot? And the cotangent at that spot is negative square root of 3 over 3. But you'll see that this is now the inverse tangent, which is now asking, okay, so what is the angle measure at negative square root of 3 over 3 for tangent? And that gives us negative pi over 6. Again, we got to say negative pi over 6 in our answer. This is where I'm going to be testing you that you understand your bounds. If you put 11 pi over 6, I'm going to get you on that one there. And I think, unfortunately for us, we may only have one more problem before we have to bust out the Pythagorean theorem. So here is problem 8, and then I'm going to move it out of the way once I get it finished. So problem 8 is going to be looking at here, okay, so where is at the tangent, at this angle, negative pi over 4, which is in the fourth quadrant here, or 7 pi over 4 if you're looking at it that way, what is that tangent value? It's negative 1. So what is the cosine at what is the cosine, the inverse cosine of negative 1, which means what is the angle measurement when cosine's negative 1? And you can see that would be pi. So that gives you your answer there. All right, so from 9 through 13, we got 5 problems where, unfortunately, you can't find any of these on the unit circle because 1/3 is not a spot on the unit circle. So what needs to happen is we need to first identify what quadrant are we in. And we'll use our bounds to kind of help us with that. So what quadrant is this in? And then what we'll do is we'll use the SOHCAHTOA properties. So let's put up SOHCAHTOA. This is our way of remembering sine, cosine, and tangent. And let's go take a look at the cosine here. The cosine, this is a positive 1/3. Now, cosine is either going to have to be in the first quadrant or the second quadrant. And since this is positive, this is going to be in the first quadrant. So I'm going to put a 1 here, Roman numeral 1, to remind me of that. And what I need to now find is I need to find a triangle that's going to help me figure some stuff out, because when we get the tangent, we're going to actually need a side that isn't identified. And what we're saying here is that the cosine, the inverse cosine, we're going to use the definition here. The inverse cosine, we don't know that angle measurement. So what we're going to do is we're going to say, okay, the cosine of theta is equal to 1/3. And cosine is adjacent over hypotenuse. So in the first quadrant, we have our angle measurement here. None of my triangles are going to be to scale, just I'll say that right away. We're going to go adjacent over hypotenuse. So the adjacent is 1, and the hypotenuse is 3. So what we need to do is find our missing side right here, which is y. All right, here. The pinball machine you hear in the background is my phone. Isn't that fun? All right, so what we're about to do now is we are going to now solve for y. Using the Pythagorean theorem, which is 1 squared plus, hold on a second here, 1 squared plus y squared is equal to 3 squared, we've got 1 plus y is equal to 9. So y squared is equal to 8. Take the square root of both sides, y is equal to the square root of 8, which I can break down into 2 square roots of 2, because the square root of 8 is the square root of 4 times the square root of 2. Square root of 4 can be broken down to 2. So our y is square root of 2 over 2. So if I want the tangent of this theta angle right there, if I want the tangent at this, tangent is opposite over adjacent. So this would be 2 square root of 2 divided by 1. So my answer to this problem is 2 square root of 2. And that would be your answer. Let's continue this logic here on these problems. The sine, square root of 2 over 3, that's not in the unit circle. You would have square root of 3 over 2, but not this one. So what we have to do is we have to think, okay, the sine of what angle is square root of 2 over 3? Let's go to SOHCAHTOA over here. SOHCAHTOA, opposite over hypotenuse. So we're going to make this in the first quadrant again. I'll put a 1 here just for first quadrant, because if this was negative, we'd be in the fourth quadrant. All right, so here we have opposite over hypotenuse. So the opposite is square root of 2, and the hypotenuse is 3. So Pythagorean theorem time. We got x squared plus y squared equals h squared. This is ABC. For these, I noticed I didn't do that up ahead. I should have really done that. But this is my x, my y, and my hypotenuse. For any right triangle, it fits there. So therefore, we're going to now plug in x squared plus the square root of 2 quantity squared plus equal 9. So this is x squared plus 4 equals 9. And then we, oh, sorry, whoa. The square root of this is 2. Oh my goodness, almost made that mistake stick. Yeah, the square of anything is the square of a square root is itself. So x squared is equal to 7. So x is equal to the square root of 7. So there it is, the square root of 7. So the sine is the opposite over hypotenuse. We figured that out. Now we need the cosine, which is the adjacent over hypotenuse. The adjacent is square root of 7. Hypotenuse is 3. Square root of 7 over 3. There's your answer. All right, let's do problem number 11. Then I'll move this down a little bit and pop my SOHCAHTOA back up on the page here. So we've got the tangent of an angle is going to be equal to negative 2 over 1. Notice I did that because the definition of tangent is opposite over adjacent. So from our angle thetas, and I've got to say to myself, now where am I at? And since this is a negative value, I am in the fourth quadrant, so I got to make my triangle look like it's emanating in the fourth quadrant. There's my theta. So in this case, this opposite is negative 2, and this adjacent is going to be positive 1, which makes sense because this is a negative y value there, and we'll just put our x squared plus y squared equals h squared. So I've got 1 squared plus negative 2 squared equals h squared. So it's going to be 1 plus 4 equals h squared. So h is going to be the square root of 5. I skipped a step there, but there's the square root of 5. Now I need to find my cosecant. And to think about cosecant is the reciprocal of this of sine. So opposite over hypotenuse. So instead of going negative 2 over 5, square root of 5, we're going to go square root of 5 over negative 2. The negative would go out in front. There's your answer there for that problem. So just make sure that you have your negative on that, as it's an easy mistake to forget it. All right, so let's look at 12, 13, and 14 and wrap this video up here. So let's go to 12, 13, 14. Do I got enough room to write it? I do. Okay, so what I'm going to do, let me get my screen draw rocking here. Okay, so here's what I've got here. I want to find if I got a cosine of theta is negative square root of 3 over 3. Well, I'm in the second quadrant. I am in the second quadrant, so here's my triangle, and here's my theta. What I'm going to do is I will be putting my cosine, and again, the KCAH of SOHCAHTOA is adjacent over hypotenuse, so this would be the negative square root of 3, because it's my negative x value from the origin here, and this would be my hypotenuse here, and we're going to figure out our y for cotangent. So what we're going to do here is we're going to say if I have the negative square root of 3 quantity squared plus y squared is equal to 3 squared. So this right here makes a 3 plus y squared is equal to 9. To see that out, this is negative times a negative is positive, and the square of any square root is itself. So y squared is equal to 6, and then we will then take the root of both sides. Y is equal to the square root of 6. So with that in mind, that is our y value, the square root of 6. So we're now going to take the cotangent of this angle. The cotangent of that theta is going to be, tangent is opposite over adjacent, so this would be adjacent over opposite, and that would give us this weird fraction of negative square root of 3 over square root of 6. And no, we can't leave our answer like that. We have to rationalize the denominator, multiplying top and bottom by square root of 6 over square root of 6. Doing this, multiplying by a very fancy looking 1, this gives us negative square root of 18 over 6. This numerator can be can be simplified further, because the negative square root of 18 is like saying the negative square root of 9 times the square root of 2 all over 6. So this is negative 3 times square root of 2 over 6, or I can simplify that to negative square root of 2 over 2. So there it is. That is your final answer to the problem, and wow, what a problem it was. Okay, so for another problem right here, we're going to take a look at another situation. So we're going to have the tangent of theta is equal to 1/2. I am in the first quadrant. It's nice to have these easy first quadrant problems here. Tangent is opposite over adjacent, so 1 over 2. I'm not going to write down my Pythagorean theorem. 1 squared plus 2 squared is 5. This would be the square root of 5. Now we're going to have to take the cosecant of that. The cosecant is the reciprocal of sine, which is opposite over hypotenuse. So we take hypotenuse over opposite, and the hypotenuse is square root of 5. The opposite of that, theta, would be 1. So the answer is square root of 5. So again, the cosecant is 1 over sine. So this would be, instead of opposite over hypotenuse, this is hypotenuse over opposite, and hypotenuse is square root of 5. Opposite from the angle theta is 1. Okay, now this is going to require us to do a little bit of interesting thinking here, because 7 pi over 6 is the wrong angle right there, because but it can work because this isn't an inverse. But what you may need to look at is, you need to look at this on a unit circle. It almost goes all the way around. Actually goes, I'm sorry, just goes just past. This goes just past pi right there. Oh man, I'm off on my last problem here. I'm excited to be finished. So this is the cosine of negative 1/2. And then we look and see where is the cosine of our negative 1/2, and that's going to be equal to 2 pi thirds. Wow, that was not as hard as I thought it was going to be. All right, well, thank you very much for watching the first of 2 videos that I'm going to make for this worksheet. So thank you for watching.